Welcome to Petrophysics 101. Today we're diving into the most fundamental property of any reservoir rock, porosity. Simply put, porosity is a measure of a rock's storage capacity. Think of a kitchen sponge. How much water it holds depends on the empty spaces inside. In reservoir rocks, these empty spaces are called pores, and they're what hold the precious fluids, oil, gas, or water. Mathematically, porosity, denoted by the Greek letter phi, is the ratio of the pore volume, V pore, to the total bulk volume, V bulk, usually expressed as a percentage. Not all pores are created equal. We classify porosity into two main types, total or absolute and effective. Total porosity, phi-T, is the volume of all voids, connected or isolated in the rock. It represents the absolute maximum storage potential. But for hydrocarbon recovery, we only care about the pores that are interconnected. This is effective porosity, phi-E. These are the only pathways fluids can use to flow to the wellbore. In a reservoir engineering context, effective porosity is the value that truly matters, as it controls both storage and the ability of fluids to move. Porosity is also classified by its origin. Primary porosity, or intergranular porosity, develops at the time of deposition of the rock. It's the space left between the original sediment grains. This is typical of sandstones. Secondary porosity develops after the rock has been deposited and solidified. The main types are vuggy or moldic and fracture porosity. Vuggy porosity consists of large holes, or vugs, created by the dissolution of unstable components often seen in carbonates like limestone. Fracture porosity is created by tectonic stress, forming thin cracks that can drastically improve fluid flow, even if the rock matrix itself has low intergranular porosity. So, how do we measure this critical value? In the lab, we use a clean, dry rock sample called a core plug. A common method uses a helium porosimeter based on Boyle's law. Because helium is inert and its molecules are extremely small, it penetrates almost all pores. The porosimeter calculates the grain volume, V grain, the space occupied by the solid rock material. We then find the pore volume by subtracting the grain volume from the bulk volume. The resulting measurement is typically a very good estimate of the rock's effective porosity. Why is porosity so important to us as engineers? Porosity is the direct measure of a reservoir's capacity to hold hydrocarbons. A small change in porosity can mean billions of barrels difference in total reserves. It is the crucial first step in reserve estimation and dictates the commercial viability of a field. Understanding the origin and distribution of porosity, both from lab data and well logs, is essential for successful reservoir development. Join us next time as we explore a concept that's often confused with porosity, permeability, the measure of how easily fluids can actually flow through those pores.